All right, name something that we've learned about this phylum. What's the phylum? Is that a phylum or a class?
I don't know.
Okay, the phylum is mollusca or mollusks. So give me an example of a mollusk. That's one. Clams? Snails, okay. So what are the classes of clams and snails?
Gastropods or snails.
Gastropods or snails?
And Bolivia.
Yep, bivalvia, you know what you mean. Yep. So with that, then we move on to the most complex of the mollusks, which are the cephalopods. We will continue that video here shortly. That was on PBS about the cuttlefish. I think, yeah, this is where we left off with, correct? And then this is where we begin.
No, we haven't.
Oh, okay. So when we look at this, what's significant about a shell in regards to this phylum? Is it just unique to these guys, the cephalopods? No, it's not unique to the cephalopods because all mollusks have a shell. Either it's on its back, or it's inside its mantle cavity, or it actually surrounds the entire mantle cavity. Now, when we look at this, the most complex, as we said, are the cephalopods. Okay? With that, gas chambers. This is talking about the nautiloids, or the nautilus, which is also considered that of a cephalopod. And what we mean by that, okay, allows the animal to become more buoyant and can swim while carrying its shell. Okay? So what we mean by that is the shell is actually on the outside of nautilus or nautiloids, nautili, however you want to pronounce the plural form of that, where it's on the inside with squids, cuttlefish, and octopods. So again, when we're talking about this shell, when it comes to just the nautilus only, the living portion of the animal inhabits the last chamber because this shell is on the outside of this cephalopod, not on the inside, like it is with the other members of this same class. And one way to look at this, okay, for locomotion purposes in that of the other two members of the cephalopods, octopods and squids, okay, they can fill a portion of their mantle cavity and then they forcefully contract that mantle cavity and push water outside of this funnel. And what happens is, just picture having a balloon, for instance. Okay, use this fly swatter here as an example. So if this portion, like the mantle or the balloon, is filled up with air, but with these animals is filled up with water instead, once they forcefully expel that water, or you let the balloon go over here, as that air or water is being released, and it forcefully expels the water this direction, or if the air is being let go, what direction does the balloon or the cephalopod move then? It moves in the opposite direction. So that's what we're talking about here as far as forcefully expelling water through the mantle cavity. So as it does that, it moves in the opposite direction. Okay? That's a little different than the nautiloids because they just bob or bobble along in the water currents because their shell, again, is on the outside. So the funnel, one of the things that we see about that, if you are moving one liquid substance from another, the top of the funnel is quite large. The bottom of the funnel channels it down. Okay? So what happens to the speed of that as it gets down towards the bottom of that? Does it slow down or speed up? It goes quite slow, but as it channels that, typically it'll speed that up. Okay? So which you might think, well, that doesn't make any sense because I'm filling this with liquid. Well, typically, if that's what happens when you constrict that into a smaller area. But as you're pouring it in a funnel, there's no pressure behind it. But if you were to be able to put pressure on that funnel, it would be moving much, much faster. Okay? But when you're doing it with just pouring liquids from one bottle to another, the reason it goes so slow is you don't have any pressure behind it because it's just open to the atmosphere. It's a little different with this because that's closed to the rest of the water. So when it contracts, it forcefully expels that water. It moves in the opposite direction then. Okay, so where does that put us? We are on slide 23 of 29. What do we got next? Okay, let's just do, this will be the last one today, and then we'll get that video rolling. So the Nautilus, the external features, okay? It's got 2 pairs of gills instead of 1, and that's something that you will notice when you dissect these squids. You'd only find 1 pair of gills. Same thing with bivalves. They've got 1 pair of gills, but for some reason, when these animals evolved, they got 2 pairs of gills. Now we're talking about the nautiloids now. Because as we look forward to the rest of this week, there will be your short answer papers assigned tomorrow, which will then be due, looks to me like, gosh, I have next Friday down. I think that's way too late. I'm thinking maybe that we might move that up to the 10th. Okay. We'll see once where we end tomorrow and I actually hand them out, because I think having over a week is plenty of time to get this done. Okay, so that's where we'll stop for today. Tomorrow, again, we'll hand out that paper and continue talking about the cephalopods. So you're going to start to explain some of these features on why some of these animals belong in this class, but yet how they are different, because like leuconoids, cycanoids, and ascanoids, yes, they're all peripherans, but some of them are larger or they have more than 1 oscula. Then you go on to the cnidarians. You have the, the sea anemone, which is in the class Anthozoa because it doesn't move. The crown of tentacles is going up instead of down. So even though they're in the same phylum, they're in a different class with other members of animals in that phylum, the clams or the slugs and snails. Okay, we'll catch up to you next time.